this is there's our pretty low. For the 15 volt IMS 50 half. So supplies the foreign loads. The low one is a 100 kVA Powerfactor 0.75 Powerfactor lagging. Low 2 is a 50 kilowatt 0.8 Powerfactor lagging. And low 3 is a 20 kVA 90 degrees leading. And low 4 is 60 kilowatt and 90 kVA leading. So we have to calculate the real power, reactive power, apparent power, power factor, and also determine the capacity required per phase to raise the power factor to 0.95. Okay, firstly we have to calculate the low one. kVA given, so kVA means this is the low one here. The power triangle. The horizontal is the real power. The vertical is represent the reactive power, and this hypertenue represent the apparent power. So this is become the 100 kVA. And power factor 0.75 decade. Again, so this angle theta 1. So theta 1 you can calculate cos inverse 0.75. So then you can got the angle. This angle become the 41.4 degree. So this theta 1 is 41.4. So this real power you can calculate. So this is the S1. P1 is P1 is the real power. The Q1 is the apparent power. So P1 you can calculate 100 cos 41.4. So this becomes the 75 kilowatt. And the Q1 100 sine 41.4. So 100 multiplied by 41.4, you got the 66.1 kVA. So we got the low one, we can calculate, and also we can calculate for the low 2. So low 2 is 50 kilowatt 0.8 power factor lagging. So then you can calculate theta 2. Theta 2 is cos inverse 0.8. So this becomes 36.8 degrees. So low 2 is a 50 kilowatt. The horizontal wave is a 50 kilowatt. P2 and this is a Q2. So this angle is 36.8. So Q2 is equal to P2 tangent 36.8. So this becomes a 50 tangent 36.8. So 50 tangent 36.8. So by solving this one, you got the 37.5 kVA. So this is for the Q2. And also the low 3. Low 3 is 20 kVA and 90 degrees angle leading. So this is only this one. This is the Q3. So 20 kVA. And low 4 is and 60 kilowatt and then 90 kVA angle leading. So this is a low 4. Low 4 is also 60 kilowatt. Horizontal is 60 kilowatt. So this is a P4 is 60 kilowatt. And Q4 is 90 kVA. Leading means this angle is a theta 4 here. Okay, so then we all the main you got, and then you can calculate the all power. So all power total you can calculate PT, P1 plus, P2 plus, P3 plus, P4. So all the real power you add P1 plus, P2 plus, P3 plus, P4, you got the total real power. So this total real power means that P1 is only called the P1 75 plus P2 is 50. P3 does not have the P3, only the reactive component is 0, and the P4 is 60 kilowatt. So by solving this one, you got the total real power. So total real power is 75 plus 50 plus 60, so you got the 185 kilowatt. And also you can calculate the QT. QT is a Q1 plus, Q2 plus, Q3 plus, Q4. Okay, so Q1 is 36.1 plus Q2 is 37.5. Q3 is 20 and Q4 is 90. Then you got a Q total. This total is kVAR main. So this, then you can calculate. So this is kind of 110, so 66.1. So this is the 63.1 plus 37.5 plus 20 plus 90. So 213.6. Okay, so this is one that we can go, that's 213.6. Then you can calculate the power factor. So this is the power factor total. So power factor, people calculate, you can calculate the angle theta. So tangent theta T.
Get you, is that just a number or just a rate or?
No, this is a kVAR. Okay, so tangent theta T is equal to the kVAR total divided by kilowatt total. So kVAR total is 213.6 and the kilowatt total is 185. So this is the 206 divided by 185. So you got the 1.154. So theta total is equal to tangent inverse 1.154. So the 1.154 tangent. So inverse of tangent 1.154. So 49 degrees. So this is the angle is 49 degrees. Then you can also calculate the power factor total. So cos theta total. So this is cos 49. So this is cos 49. You got 0.656. Okay, this power factor is poor. You got only 0.656. So we want to increase the power factor to the 95%. So 0.95. So this means theta 1, theta total 1 is equal to 49 degrees. So power factor total 2. Power factor total 2 is equal to 0.95. So this becomes cos theta total 2 is equal to 0.95. So the theta total 2 is equal to cos inverse 0.95. So the inverse of cos 0.95, you got the 18.2 degrees. So theta total 1 is 49 degrees, theta total 2 is 18.2 degrees. So we have to calculate the power factor improvement. So the formula is kilowatt total, so kVAR total. So the formula is kilowatt kVAR improve. kVAR improve is equal to kilowatt total multiply tangent theta total 1 minus tangent theta total 2. Firstly, you can calculate the kVAR improve. So the kilowatt total 1 is 185. The tangent theta total 1 is 49. Tangent theta total 2 is tangent 18.2. So we saw that this one. So this is tangent 49. You got that 1.154. Minus tangent 18.2. So 0.328. So you solving this one. So 1.154 minus 0.328 and then multiply with 185. So you got 152.81. So this is the kVAR. This kVAR need to be improved by the three-phase capacitor band. The formula is, so this is the three-phase power. So this is three-phase power. So 400 variable means that we assume that this is the three-phase. So the kVAR improve divided by root 3 is equal to phase voltage square divided by 1 by 2 by FC. So this is the equation. The equation to calculate the capacitor. So you substitute here. So this is a 152.81 divided by 2. So this is a power 10 power 3 phase voltage square multiply with 2 by ST. So this is a 152.81 divided by 3. You got there 50.9 into 10 power 3. Phase voltage is a 415 divided by root 3 square. 2 by 3.1416 and 50 and the capacitance C. Then you can go the capacitance C. So this is a 50.93 into 10 power 3 divided by 240 square and 314.16. Then you got the capacitance. So 50.93 multiplied 1000 divided by 240 divided by 240 divided by 314.16. So this is a 2.814 into 10 power minus 3 farad. So this is begun there. So multiply with 10 power minus 6. So 10 power 6 begun a microfarad. So the 2.814 into 10 power 3, so 2814 microfarad. So this is our 3-phase load. At 415 volt IMS 50 half. So supplies at 40 loads. The load 1 is a 100 kVA Powerfactor 0.75 power lagging. Load 2 is a 50 kilowatt. So